Okay, good morning, Year 12. I thought I'd do for you a recording for questions 11 and 12 on page 15. I'm leaving you to go through this video and to see if you understand how to get these graphs. I will talk you through it because we are going to be moving on quite quickly. All right, now they've given you an exponential graph doing something like this, okay? There it is. And what I've gone and done is I've sort of, this dotted curve here is sort of like the standard exponential, y equals a to the power of x. And it's important because it goes through this all-important point here of 0, 1. Because when x is 0, anything to the power of 0 is 1, so y is 1 at that point. All right, now you will notice that this point here, this all-important point on this curve, that the x-axis itself is an asymptote for this curve there, this standard curve. And you'll notice in the curve they've given you that the new asymptote is now at y equals 1 for this curve here. And just as with the standard curve, this all-important point is 1 unit above the x-axis asymptote. So this point here on the new curve is 1 unit above the new asymptote. Now that's very important because you need to ask yourself, where does this all-important point go on the standard exponential curve? Where does it go in the new curve? Well, the new point is there. So in other words, this point, which is 1 unit above the asymptote of the x-axis, is now 1 unit above the new asymptote there. So how did it get there? Well, it must have done something like this. It must have gone 2 units to the right and then 1 unit up. Well, how does that make this equation change? Well, it changes it like this here. Okay, your a is the base number, which we still don't know, and it goes raised to the power of x minus 2. Minus 2 because it's gone 2 units in the positive x direction, so we have to write minus 2 there. We have to think counterintuitively and write minus 2 there. And then it's been shifted 1 unit vertically, so there we have that plus 1 on the end for that vertical shift, if you like. And now we use a point that sits on this curve to find a. And the point I've used is this 3, 4 here, which sits nicely on the curve. And so when I do that, the 4 for my y goes there, my 3 for the x goes there, and so we can now work out what a is. We'll take the plus 1 over the equal sign, it goes to minus 1. And so what we've got is that 3 is equal to a to the power of 1. Because 3 minus 2 is just 1. So this means that a is itself just 3. So the formula for this first curve is y equals 3 raised to the power of x minus 2, and then all plus 1. Now this is achieved, and if you're wanting to get more than achieved, you really must be looking at listing the features, the domain, and the range of this graph. Okay, so what is it? Well, it's a positive exponential, so that's the name of the curve. You must write that in. Because it would be such a pity if you got the formula lovely and correct, but you didn't actually give it its name. Okay, so you also should be mentioning what is the asymptote. Well, there's an asymptote at y equals 1. There it is there, and that must be stated. However, there is an y-axis intercept just there, just a little bit above 1. Well, how on earth do you find its value? Well, if it's crossing the y-axis, this must be when x is 0. So you use your equation, and I've shown you how to do this here in this bubble. You use the equation you've got, and you set your x equals to 0, as I've shown you here. So there it is, x is equal to 0. And this makes that y is equal to 3 to the power of minus 2, all plus 1. Well, this 3 to the power of minus 2, if I write the 3 underneath a fraction and make it 1 over 3, well, that minus 2 goes to plus 2. And 3 to the power of 2 is 9. It's 3 times 3 is 9. So it's really 1/9 plus 1, which is 1 1/9, or as I like to write it as a top-heavy fraction, it's 10 over 9. And so that there is they are the coordinates of the y-axis intercept, 0 and 10 over 9. Now, what is the domain of this exponential? Well, you can draw this exponential for all values of x. So the domain is all values of x. Now, let's look at the range. Well, this is all the values of y, but unfortunately, this curve, this exponential curve, it never drops below y equals 1, below this asymptote. So it doesn't exist for values below y equals 1. And that's what you must state with the range. So the way I've written it is this. The range is all values of y such that, that's what these two dots mean, okay? All values of y such that y is greater than 1. Okay, not greater than or equal to. It can never equal y equals 1 because it can never touch this asymptote. Okay, and the curve therefore exists only for values of y which are greater than 1. All right, so you've mentioned that as your range. Okay, now let's look at question 12. There we have it. Now, question 12, the curve is now doing something like this. It's still an exponential, but if you look at the original exponential like that, you'll see that it seems to have been reflected in the y-axis. So this part is now over there, and this part of the standard exponential is now over here. So it's been reflected in the y-axis. This means that it must start like this. Y equals a, some base, to the power of minus x. Okay? Now, in this curve here, there has been no vertical movement of the curve, and there's been no horizontal movement of the curve. How do we know this? Well, we know this because it still goes through that point there, 0, 1. Okay, and I've sort of talked about that there. Now, we need to find the base A. Well, if you look at your graph, you'll find that it goes through a nice point, minus 1, 3, there. And so we use those values in our equation there to find A. Well, my y is 3, my x is minus 1. Now, I must be super careful here because this minus sign is not that minus sign. Okay, it's going to stay there, and this minus 1 is going to have to be put in brackets, which means that that minus and this minus are going to change to plus 1. Okay, so your A is really 3 to the power of 1. Okay, so in other words, the graph's equation is y equals 3 to the power of minus x. So we found that A is positive, it's 3. So we write it like that. All right, now what are the features? Well, the features are that it's a negative exponential because it's been reflected in the y-axis, and that the x-axis is the asymptote. You can see it's coming down, it's approaching the x-axis, but it never touches the x-axis, so the x-axis is an asymptote. The y-axis intercept, of course, is that all-important point there, which is at 0, 1. So you must give the coordinates of this. And again, the domain is all the values of x, because this graph can be drawn for any value of x. But now we must be careful again, because when we talk about the range, we're saying what are the y values for which the graph can be drawn? Well, it's all the y values which are greater than 0. And that's what I've said down here. And this is how you read this. You read this like this. The range is all values of y such that y is greater than 0. Now it's greater than, it's not greater than or equal to. It's not or equal to, because it must never touch the x-axis, because the x-axis is the asymptote. Okay, so y has got to be not 0, but greater than 0. Okay, so I hope that helps with this, the understanding of exponentials. And thank you very much for listening. Okay, goodbye.